I'm here to mention how we want to repurpose Lactobacillus plantarum to become a pathogen sensor. And the title of the presentation is the Rapid and Cost-Effective Bacterial-Based System for SARS-CoV2 Testing. Now, we all know what COVID-19 has, how COVID-19 has transformed our lives. The image is from Google. I took it today. Right now, we have 127 million cases, and globally deaths account to 2.7 million. And when we're dealing with a problem with such a magnitude, the important question is what can we do at a very small, let's just say, level? What can we do with our resources to kind of contribute to alleviation of the problem? And so me, Dr. Tusa Warrior, and Dr. Mukul Prasad, all of us are NUS alumni, decided that we can do something about the diagnosis of the virus. So the spread of the virus is very important, particularly when we think about asymptomatic people who can carry the virus, coming in contact with risk groups, meaning aging populations and people afflicted by chronic disease. Now, the second thing we realized early on is that there is a huge difference between let's just say, the proximity to qPCR-based testing. So even though in Singapore, for example, we have the ability to use qPCR machines, and we can reach all the way up to now 15K PCR tests per day, that is not the case for developing countries. So we wanted to build a system that will not depend on fancy equipment. So what we plan to do, and I say plan to do because we are building this system now, we believe it's going to be ready 6 months from now, is we want to have cheaper and faster diagnostics. We want our system to be portable, and we want it to be consumer grade. Of course, if the technology works really well, we want to use it, repurpose it for multiple antigens. We want it to be easily packaged, and we think it can be, it can form an intellectual patent. Now, what is the core of the technology that we want to use? We have three main phases: the sense, compute, and respond. And what we mean by that is that the bacteria have the ability to sense the environment and detect the presence of bacterial proteins, viral proteins or viral RNA, have the ability to relay the information in their cytosol, and finally, the information allows the bacteria to respond by expressing a colorimetric protein, a chromogenic protein, which has a purple vivid color. Okay, so how do we do that? A few things I can mention already. We can allow the detection of viral proteins by anchoring specific antibodies from the Camelidae species, meaning camels, llamas, alpacas, on the surface of Lactobacillus. Once the spike protein of the virus has been attached to the Lactobacillus displayed nanobodies, it triggers a response in the cytosol of bacteria that activates the transcription of a colorimetric gene. Now, the bacteria can lyse with by triggering what we call an FX174 lytic gene that has the ability to break the membrane, and therefore releasing the chromogenic protein. Now, who are we? I'm Stylianos. I'm the founder of FalconBio. My colleagues participating in the work is Dr. Tusa Warrior. He's an expert in epigenetics and molecular biology, and Dr. Mukul Prasad is an expert on COVID-19 vaccines. Our scientific mentor for this particular endeavor is Dr. Jonathan Lowe. He's a senior principal investigator of the Institute of Molecular and Cell Biology, and Dr. Shadi Al Farhan, who is a research fellow at the Broad Institute. Our financial advisor is Miss Julia Serengina, and we, as partners, we have chosen GenScript Biotech and Twist Biosciences for obtaining all the synthetic DNA to build the sense, compute, and respond technologies. And most importantly, the project is supported a very small grant from the NUS Resilience and Growth Innovation Challenge. And with that, I would like to take your questions.